Next problem is 15-43. The bullet problem consists of a bullet which has a mass of 20 gram. It is initially moving with a velocity of 400 meter per second. After this, the bullet penetrates the stationary block. The mass of the block is 2 kilogram. So we have to find the distance the block will slide before it stops. The coefficient of friction between block and the plane is given. Initial velocity of the block is 0. Initial velocity of the bullet is 400 meter per second. We will find the velocity. We will calculate initially the velocity at which both will travel. That is after when the bullet penetrates into the block. So this is the condition. The bullet is penetrated into the block. These are the forces. We consider the time interval between the initial condition and when the bullet penetrates into the block. So this is the conservation of momentum. For a system of particles, there are two particles involved. One is the block, other one is the bullet. And for this time interval, that is initial up to the point where the bullet is embedded, there is no impulsive force. There is no impulsive force between this time interval. So the momentum will be conserved. Initial velocity of block is 0. The subscript small v is for bullet and capital V is for the block. This is mass of bullet, velocity of bullet, then mass of block, velocity of block. Then this is the total mass and this is the common velocity. When the bullet is penetrated into the block, there will be a common velocity which is written as VBB. So the common velocity or common initial velocity is 3.96. That is at the instant where the bullet strikes the block, the initial velocity will be 3.96. Then there is no motion in the y direction, so we will not perform any calculations in y direction, but only we will determine the friction force which is due to the normal reaction. So normal reaction will be equal to weight mass multiplied by g, and friction force is coefficient of friction multiplied by the normal reaction. This gives 3.96. Then we apply the impulse and momentum equation. Now here location 1 or point 1 or instant 1 is where the bullet is penetrated into the block. That is the instant where the velocity is 3.96. When the two particles, two embedded particles or two combined particles will move, due to friction the velocity will reduce. So we apply the impulse and momentum equation between the instants where the velocity is 3.96 up to the instant where the velocity becomes 0. So initial velocity is 3.96, then friction force, it is the only force in the x direction, 3.96 again, and then multiplied by t or delta t. Since friction force is constant, we can move out of the integral sign and we can simply multiply with time t or delta t. So we get a relation between velocity of the block plus bullet and time. We are interested in the velocity and distance, where the block is stopped. So when velocity is 0, time is equal to 2.02. Then we determine the distance the block travels. So ds is equal to v dt. We have a relation of v. We integrate the distance is from 0 to s. Reference position is 0 and time is 0, and finally the position is s, time is t. Now at time equal to 2.02 the block will stop, so we substitute t equal to 2.02. we get distance of about 4 meter. This means after 4 meter the bullet plus block will stop. There will be some initial velocity, but after 4 meters the block will stop. Next problem is 15-53. In this problem there is a block of mass 5 kilogram and there is a triangular block B which has a mass of 30 kilogram. The block A is released from rest. Similarly, the block B is initially at rest. We have to find the distance the block B moves from point O when A reaches the bottom. If there is some friction between the triangular block and the plane surface, the triangular block can remain stationary. But here the block is smooth, or the plane is smooth, so when block A moves downward, block B can move towards right. That is, when the block A is moving towards left and down, then block B can move towards right. The length of the block, the horizontal distance is 0.5. So we have to find the distance covered by block B when A moves up to location 2. Beginning from 1, when it reaches 2, we have to find the distance traveled by the block B. So these are the velocities. There will be y component of velocity and x component of velocity of block A, but we will be calculating the velocities in x direction mostly because block B can only move in the y direction. Sorry, the block B can only move in the x direction. So we apply the conservation of momentum equation between location 1 and location 2, or instants 1 and 2. There is no impulsive forces for the system of particle. The system of particle consists of 2 blocks. One is block A and block B. So for these 2 in combination there is no impulsive force. So momentum or total momentum will be conserved. Initial velocity for block B and block A is 0. We are performing calculations in x direction since the blocks were at rest. The initial momentum is 0. So left hand side of the equation becomes 0. Mass of block A is 30 and mass of block B is 5. Mass of block A is 5 and B is 30. Then the mass of the velocity of block A is towards left, so we include a negative sign, and mass of block B, we assume that it is moving in the positive direction. So we get a relation between velocity of A and velocity of B in x direction. So this is one equation. Then we solve the equation of kinematics for the relative conditions. We are familiar with this equation. We write this equation for the x direction. Block B is only moving in x direction, so we are not including x in the subscript. In this equation, A to x, VA to x can be written in terms of VB2. So VA to x is equal to 6 VB2. That is, the velocity of A will be 6 times the velocity of B. So by solving these two equations, so velocity of A is in the negative direction, so we include a negative sign, and after calculation the velocity of B with respect to A in x direction is 7 times the velocity of B at any instant, at any instant 2. After integration we get the position relation. So the position or the distance covered by B with respect to A in x direction will be equal to 7 times the distance covered by block B. So we can see the distance covered by block A with respect to B, or we can write the distance covered by B with respect to A. With respect to A, the distance covered is 0.5 meter, because when A reaches up to the bottom, the relative distance covered by A is 0.5 meter. So we substitute 0.5 in this equation, we will get the actual distance covered by block B. So actual distance covered by block B is 0.5 divided by 7, and this gives 0.071. So the relative distance covered is 0.5. A moves 0.5 distance with respect to B, or we can say that block B moves 0.5 distance, 0.5 meter with respect to A, but the actual distance covered is 0.071 meter. Now we start the topic of impact. Previously we discussed the impulse and momentum equation, and we also discussed the conservation of momentum equation. Those equations can be utilized to understand the behavior of the colliding bodies. So principles of impulse and momentum have important use in describing the behavior of colliding bodies. We can determine the characteristics, the dynamic characteristics after the bodies collide with each other. Usually we know the initial conditions, initial velocity, and after collision we can predict the velocities that occur after the collision. So we start with the definition of impact. Impact is collision between two bodies, and along with the collision there are large contact forces, and the period of interest, the duration of interest is of small duration, small time. So in the definition of impact we are considering the collision between the two particles, and in addition, while there is collision there are large contact forces, and during the contact force the duration of the contact force is usually very short. So in the definition of impact, these three conditions are there. Now impact is a complex event. When there is collision, there is material deformation, and once the impact occurs, the recovery takes place, and during this period there can be significant generation of heat and sound. The examples of impact: the striking of a hammer on a nail or a golf club on a ball. These are two common examples of the impact loadings. In the engineering applications, there can be several examples of impact. During the many production processes, there is impact loading, and the period of the impact, the period of the collision is very less. There can be two types of impact for two particles. One is central impact and other one is the oblique impact. You can see the figures of the two cases. This is central impact, this is oblique impact. To understand the central impact, suppose the two particles are moving in a horizontal direction. The two particles are A and B. Velocity of A is VA, velocity of B is VB, and the two particles collide, and when they collide with each other, there is some area of contact. The plane which is passing through the area of contact is the plane of contact. Then there is line of impact. The line of impact is the line which passes through the mass center of the two bodies. This is the mass center of A, this is mass center of B. The line which passes through the mass center is line of impact. Then this is the direction of velocity. In this figure, the direction of velocity is horizontal. VA and VB both are in X direction. In this case, the two particles are in contact. This is the instantaneous condition, snapshot, when the two particles collide. If you draw a line passing through the mass centers, it is again horizontal. And if we draw a plane passing through the area of contact, then it is vertical. But the direction of the particles from where they are coming is inclined to the line of impact. So here we have two angles. One is theta, which is the inclination of the direction of A with respect to horizontal, and phi, which is of B with respect to the horizontal. So this is oblique impact. So here we have two terms: line of impact, the line which is passing through the mass centers; plane of impact, which is passing through the area of contact; and the third one is the direction, initial direction of the particles. Now we do analysis of central impact. Suppose the two particles are moving in the same direction, VA, VB. If the velocity of velocity of A is greater than velocity of B, then the impact will occur. So this is the initial velocity and this is the condition before impact. In the second phase, the two balls come in contact. When they come in contact, they apply force to each other. The symbol of force in this figure is P. Particle A applies force on B and particle B applies force on A. The direction is opposite. Force multiplied by time dt gives the impulse. Now this is the deformation phase. In the deformation phase, the two particles come in contact and they try to merge with each other, and the shape of the two particles is changing, they are deforming. Then in the third phase, there is maximum deformation. A and B are maximum deformed and they move with a common velocity, which is v. Then in the fourth phase, the two particles or two spheres try to separate with each other. This is the restitution or restoration phase. They are in contact. Particle A is applying force on B, particle B is applying force on A, and the impulse is R dt. R is for the force during the restitution or restoration phase. Finally, the two balls are separated, and when the separation occurs, the velocity of B increases and it is greater than the velocity of A. For the separation to occur, the velocity of B should be greater than velocity of A. So there are 5 phases during the impact process, and there is deformation impulse in the deformation phase, there is restitution impulse in the restoration phase, and in the middle we have the maximum deformation and we have the velocity, a common velocity through which the two balls are moving. Now the impact depends on the type of impact, or the condition after the impact depends on the elasticity of the two bodies. If the two bodies are not elastic, they are plastic, then there will be no restoration. There will be permanent deformation. For the elastic objects, the two particles will return to its original shape. The physical conditions are such that the deformation impulse is always greater than or equal to the restitution impulse. During the restitution phase, restoration phase, the force applied by the two particles is relatively less. And in such conditions we achieve that the velocity of B after the impact is greater than the velocity of A after impact. Usually in these types of analysis we already know the initial velocities and we have to find the final velocities. Now we apply the conservation of momentum for a system of particles. The system consists of two particles A and B, and there is no other impulsive force for the two particles. One particle is exchanging momentum with the other, but when we consider both of the particles, there is no impulsive force. So momentum will be conserved. So this is the conservation of momentum equation. So this is again our assumption that during the contact process, there are large internal forces. So when we consider the two particles, the force applied, the restitution impulse or deformation impulse is like an internal force. So there are internal forces for the two particles, but there is no external impulse. So this is one equation which can be solved, which can be utilized for determining the final velocities. Now we write the equation of impulse and linear momentum for two particles individually. So this is for particle or ball A. This is impulse momentum equation during the deformation phase, and this is the impulse momentum equation for particle A for restitution phase. Initial momentum of A plus the force applied by B on A during the deformation phase, and this is the final momentum. This is the final momentum for the deformation phase. So final momentum, the final condition for the deformation phase is this V. This is the final phase for the deformation. Then this is the impulse and momentum equation for the restitution phase. So for restitution phase, this is the final condition and this is the initial condition. When maximum deformation occurs, this is the initial condition for the restitution phase. So initial momentum plus the force applied by ball B on A during the restitution phase. So now we define a term which is called coefficient of restitution. So coefficient of restitution is the ratio of restitution impulse to the deformation impulse. So this is by definition. We calculate the restitution impulse from this equation and deformation equation from this equation. So we get coefficient of restitution in terms of velocity of particle A. In the similar manner, we write the impulse and momentum equation for particle B. When we write equation of impulse and momentum for particle B, then mass of B multiplied by the initial velocity of B during the deformation phase plus the force applied by particle A on B. This will be equal to final momentum of B for the deformation phase, mB multiplied by V. Then another equation, initial momentum of B for the restitution phase plus the impulse applied by block or ball A is equal to final momentum of ball B, which is mB VB2. So similar to the two equations of A, there will be two equations for B, and then eliminating and using the definition of coefficient of restitution with respect to ball B, we will get coefficient of restitution in terms of velocities of ball B. Now if you see two equations, we have several velocities: velocity of A initial final, velocity of B initial and final, and in addition we have velocity V. This velocity V is the velocity which is common for A and B. Now during the impact process or the collision process, the duration is very short. It is for less than seconds, less than a second. The initial velocity is usually known and final velocity has to be determined, or it can be calculated, but the intermediate velocity where the deformation is maximum, it cannot be easily determined. So in this equation we can eliminate small v. So we solve these two equations, we eliminate v, and then we get coefficient of restitution in terms of initial and final velocities of block A and block B. So this gives a second definition of coefficient of restitution. One definition is restitution impulse divided by deformation impulse. This is the definition of coefficient of restitution in terms of velocities. That is the relative velocity of two particles final divided by the relative velocity of two particles initial. In this derivation we assume that two particles are moving in same direction. If they move in the opposite direction, then we have to use the negative sign to determine the coefficient of restitution. So coefficient of restitution is difference of velocities after separation, after collision, divided by the velocity difference before collision. The coefficient of restitution has value of 0 to 1 if the impact is elastic, then the difference of velocity will remain same. Velocity of B will increase, velocity of A will decrease, but the difference of velocity will remain same. When the impact is elastic, there is no loss of energy, the energy is conserved, and momentum is always conserved when we are ignoring any other impulsive force or non-impulsive force. The impact can be plastic. This is the minimum value of coefficient of restitution, which is 0. In the plastic impact, there is no restitution impulse, there is no force which can separate the two particles. If the two particles couple or stick together, then there is no restitution impulse. And when there is no restitution impulse, there is no velocity difference after the impact. If there is no velocity difference, the coefficient of restitution becomes 0. In the plastic impact, there is maximum loss of energy. In the elastic impact, there is no loss of energy. In the intermediate values, the energy loss, the kinetic energy is converted into some other form of energy. The examples are the thermal or internal energy, which results in non-elastic impact, then it converts into sound energy, or it converts into the deformation of the material.